Each of the three plates shown in the figure has an area of 200 cm square on one side, and the gap between the adjacent plates is 0.2 millimeter. The EMF of the battery is 20 volt. Find the distribution of the charges on various surfaces of the plates. What is the equivalent capacitance of the system between the terminal points? So here this is 20 volt supply. These are three plates. Suppose battery provides minus Q charge to this plate. So on this surface, charge will be minus Q by 2. On this surface, it will be the same, minus Q by 2, because total charge supplied is minus Q. So due to induction, on this surface, charge will be plus Q by 2, and on this surface also charge will be Q by 2. Here, if we consider positive terminal of the battery, it will provide charge Q, so which will be equally distributed. So this plate will receive Q by 2, which is already here, and this plate will also receive Q by 2, which is already here. So on the outer surfaces, there will be no charge. Now we find the capacitance between these two plates. So that is C equal to epsilon naught A divided by T. We put the values 8.85 into 10 to the power minus 12 times plate area 200, 10 to the power minus 4 divided by separation is 0.2 into 10 to the power minus 3. Now we simplify it. So on simplification, we will get this as 0.885 into 10 to the power minus 9, or we can write this 10 power minus 9 as nanofarad. This is farad. Now we have to find out the value of Q by 2, applying Q equal to CB. So here Q by 2 equal to, suppose, small q equal to C. C is this much, 0.85. So 0.885 into 10 to the power minus 9 into voltage is 20. So if we simplify, this will become 17.7 into 10 to the power minus 9 coulomb, or 17.7 nanocoulomb. Now we have to find out what is equivalent capacitance of the system. So this is equivalent to two capacitances in parallel. So total capacitance C equivalent will be C1 plus C2. Since both the capacitances have equal value, so it will be twice of previous value, 0.885 into 10 to the power minus 9. So this will become 1.77 into 10 to the power minus 9 farad. Now let's go to next question. Find the capacitance of the infinite ladder shown in the figure. Here this capacitance is C, this is C, this is C, means all capacitances are C. We have to find out equivalent capacitance. So let's denote the equivalent capacitance as C1, and we replace this portion by C1 because this is infinite ladder. So we can remove some portion, still capacitance will remain same. So equivalent circuit will be, this point is A, here this is C, this is C, and here this portion is removed by, replaced by C1. And we assume that this is equivalent to a capacitance C1. So C1 equal to, these two capacitances are in series, so equivalent capacitance will be CC1 divided by C plus C1, and then the same is in parallel with this C. So equivalent capacitance can be written as C1 equal to C plus C, C1 divided by C plus C1. So we take LCM. So C1 times C plus C1 equal to C times C plus C1 plus C C1. We simplify. C1 C plus C1 square equal to C square plus CC1 plus CC1. So once CC1 will cancel out, and we will get equation C1 square minus C1 minus C square equal to 0. This is, suppose C1 we assume as x, so this will be quadratic equation in terms of x. So it is x square minus cx minus c square equal to 0. We have to find out x. So x equal to, if we remember, minus b plus minus root of b square minus 4ac divided by 2a. That is quadratic formula. So c1 equal to minus b. So it will become c plus minus root of b square, that is c square minus 4ac. 4 times a is 1 and c is c minus c square. So it will go plus 4c square divided by twice of 1. So let's write it here. So c1 equal to c plus minus, this will become root of 5c square divided by 2, which will further become c1 equal to c outside 1 plus minus root 5 divided by 2. Here root 5 is greater than 1. So if we take minus root 5 as one value of C1, so that will be negative, and negative capacitance is not possible. So possible value of C1 is C times 1 plus root 5 divided by 2, which is our answer. Thank you for watching.